Now we are in the part 2 of this tutorial, and so this is the character I used in the initial video I did, and it's something I downloaded from Mixamo. It's called Mousy, and I used the animation Happy Work on it, downloaded it, and just took it into Cinema 4D. So we are going to see how we will voxelize this character, and you are going to use the same processes as shown earlier in this tutorial. So for a quick recap, we've actually learned how to create object group and set it up with the children up, so that any object we place in the object group will show in our node editor. We also learned how to set up a distribution up, and how to clone multiple objects, and also how to clone on the surface of an object. So since we know all this, we are going to apply this same principle to this character. So let's quickly set it up. So I'll come into my asset browser, and I'll come into my favorite, because I've already favorited some of the nodes like I like. So I'll quickly bring in my object group, right? And I'll actually make, so I've already placed the character in a connect object, right, so that it can be easily swappable. So I'll drag and drop the connect under the object group, double click on the object group to bring our node editor. In fact, let me drag it down here so that we can work with it, right? And let me hit pause. So type C, come to my favorite once again, and I'll look for the children up. I'll type bring in the children up. Let's connect the up to the object and the children here. Add new input, right click here and say edit resource, and let's come to the children and advance. Let's change it from none to object, right? So we basically set it up and close it. So now you can see we have our children in our child in here, which is the character, right? So we are good with the children up for now. So let's go ahead and create our distribution. So I'll type C, come to my favorite once again, and I'll look for the distribution up, right? And then the object we want to use is a cube. So I'll bring in a cube and make it a child. In fact, let me put it in a connect once again, and I'll make it a child of our object group. So you see it shows in here. And now I'll quickly for this, let me actually select, first of all, select the distribution, come to the distribution type, and what you are going to use is down here, suffix voxel solidify, right? We can use surface volume, a volume voxel fill, but because my character, let me disable, because my character has something stuff here, it doesn't have enough volume to have like cubes and stuff, unless it's really small to fill there. That's why I'm using the, so I'm using which one, the surface voxel fill, right? So that one, you distribute clones on the surface and make sure it doesn't intersect, right? But this one will be in the volume, but this one, the ears of my character doesn't have enough volume, so that's why I use the surface, right? So let's quickly change it from linear to surface voxel fill, right? And you can see immediately we have our parameter demanding the geometry we want to clone on the surface. So that's the first one, our mouse. So I'll quickly drag and connect the geometry to it. Let's enable our object group. You can see it's gone. So now if I should connect, in fact, we wouldn't connect the distribution up directly. We are going to use it through a matrix. So if I come in here, I'll type C, come to my favorite, and already I have a matrix up. So I'll select a matrix up, and I'll bring click to open this one, and I'll connect the matrix, and I'll now connect it here. You can see we have dots, some dots has been created already, right? So if I select the surface voxel solidify, I'll see the distribution up, right? I'll first of all set the thickness to 1, and then the voxel for now I'll leave it at 5, right, which is fine. So if I should hit play, I think you can see our dots are working. We've not connected the cube yet, so I'll select the cube and I'll set it to 5 by 5 for now, 5 by 5 by 5 for now, because the voxel size is 5. If I set the cube to 5, it will fit perfectly. So now if I connect this to the matrix up, like the up here, you can see our cube fixed perfectly. In fact, let me sort of give it a bit of fillet so you see 0.5 or 0.5. So you can see we have our object well like cube fitting in our object or our character. So if you want it smaller, you can select the voxels and make it like say 2. And now select our cube and make sure it's also 2 by 2 by 2. You can see it fits perfectly, but we'll set it up in a way that we wouldn't have to change it all the time. We can set it in a way that immediately we change the voxel size, it will fit perfectly, but that's later. So now basically we've set up what this is not new. You should be able to do this after watching or the initial explanation I've done. So what really we want is how to get the color of our character, right, to actually reflect wherever the cube like actually inherits the color where it is. I mean, where the cube is, it should inherit the color of the character there, right? That's what we are going to actually see how we will do that. So now that we have this in here, how do we get the cube to inherit the color of the character? And we are going to use something called closest point, right? So if I type C and look for closest closest point, you can see we have closest point here, the other ones, but the one with some cube thingy up here, let's drag in that one, right? And we can see it's asking us, so which geometries are we talking about? So the geometry we want is obviously the mousey. So I'll come in here and I'll take the mouse geometry and connect it here, right? And now it will ask us which position or which matrix are we asking about. So we can simply take this matrix and connect it here to the query position. So basically what we are saying is that wherever these dots or the matrix dots, wherever it shows, right, let me disable this, wherever these dots shows, the closest point to this geometry should sort of like, you know, recognize it. So now we've sorted this out. So now every dot sort of knows the position or knows the point it's close to. So if you select the closest point, we can actually set the distance if we have, but I think for this I'll leave it at default. So now every dot knows the point, these dots knows the point it's closest to when it comes to this geometry, right? So you can inherit its color, but we have to set it up. It knows that it's probably close to the point, but it doesn't know what it's doing here. We've not told it what to do. We want it to know the color, but how do we tell it to get the color? So we have to get the information of those points, right? So to get the information of those points, we first of all have to transfer the color. Right now the color is on the material, on this material, and we have to transfer it to those points, right? So if I should come into my mousey, let me disable the connect, select it and come to points. You can see, I mean, but it's unfortunate, like you have to probably, the point mode is not showing the animation. So you can see if I put it to point mode, we don't see the animation, right? And that's because if I come into mode and come to, I think, view settings, right, deform editing is unchecked. So if I put it on now, deformed editing, you can see now our point mode is also inheriting the animation. So what we want to know is that every point will know the color information, will have the color information of the geometry, which is this material. So how do we do that? It's as simple as just right clicking on, in fact, but let's actually right click on this connect object and come to other tags and add a vertex map, right? And in the vertex color actually. So I right click on it and come other tag and I add a vertex color, right? So we select the vertex color. Let me enable the connect. You can see it's black. It doesn't know what color. That's basically every point is black. It doesn't know the color information. So how do we get that? We can simply come into our fields and look for shader field. Select the shader field and come to the channel. It's set to custom. Let's set it to color, and the color we want to use is from this material. So let's click it, and now you can see all the vertex color has turned from black, and it's inheriting the material of this particular material. If I select, you can see now it's inheriting it. So now every point knows the color, it like has some sort of color, right? If I select it, every point has its color, right? So now we can send that information in here and tell the our dots that whenever you are close to this point, get this information. So how do we get that point color information? It's simple. We come in here, look, type C, and look for point info down here. Where is it? I think, yeah, point info, right? So bring in our point info, and you can see in the point info we have color, right? So we can use that. So it's asking us which point, which geometry are we talking about? So we'll connect the geometry once again of our mouse. You connect it to this geometry, all right? And now it's basically has information about the point. But how do we tell these two, the dot that send all the points that you are close to, gets its color information? So now we are going to use something called get elements. So I'll come in here, C, and look for get elements, right? So basically this every dot know the point it's close to, and this also we have the information of our point, right? The color information of our point. So we can simply connect it in here, the color into the array, color into the array, and then nearest indices into the index. Now C4D automatically generates this node for us, which will help us connect. And now our dots knows the point it's close to, and it's through this get element, it's getting its color, right? So if I enable our object group, and let me come in here and enable our cube, it should work. Let me actually go to object mode properly, and everything should work fine. I don't know why, but probably check. Oh, of course, like the shader field is actually has been dropped into the object group, so it's sort of not recognized. So let's drag out our shader field, and I can see our cubes are working and everything. But how do we get the color information? We have it here, but how do we transfer it to the cube? And remember, we talked about the color up. So I'll type C, and I'll come to color, and I'll bring in our color up, right? And now let's connect this matrix up to the color up and connect this. Nothing has changed, but now we can see you have the color, and the color, we don't want to use the color here, we want to use the one that we have from the get info. So we can simply drag and drop it, connect it, and you can see now every cube has the color of our object, and that's really interesting, right? So that's basically all that I did in here. Now if I hit play, you can see it's animating and everything works fine. That's really interesting. So let's quickly do some few things. So let's first of all select the object group, and remember, let's come to the generator and make sure it's set to multi-instance so that it will be faster when we are working. This is very important, because when you start changing this, it can generate a lot of clones, and it can slow your scene easily. So let's first set it to multi-instance, and let me select disconnect, make sure all this also unchecked, right? So now basically this is all the setup, right? But there's a little bit of an issue anytime I change. If I come in here, the distribution, select the distribution and change the voxel size to, like, say 1, you can see it's fine, but the cube are still big. It's like you have to come in here and make sure this one is set to 1 by 1 by 1 before everything fits perfectly, right? In fact, let's select the fillet radius and make it probably 1 or 0.2, right? anytime I do changes, I have to come in here and do all these changes, and it can make it. And so let's set it up in a way that you can easily, like, just anytime you change the voxel size, the cube will automatically recognize and fit, right? So it's very important that when you are setting this up, we make sure our cube, the size of our cube or object, is 1 centimeter, because we are going to set it up through the voxel, the distribute up. So what we are going to do is that, first of all, we will select the closest, this one, the distribution up, and hold Control and click on this, right? And you can see, let me actually undo. If you come into the distribution up down here, the inputs in here, you can see all we have is up and perimeter. But if I hold Control and click on this one, it sort of propagate this one into the port. So now we can actually have access to it in the port, right? And that's what you want. So what we can do is that now if we select our object group, and you can see we have nothing in here, just generator, operator, and everything. But now if I take this and drag it in here and add new input, you can see a new input has been created, right? And if I select the volume, you can see now the voxel size has shown here. So this is where we control our voxel size, right? So now that we have 8 in here, we want to use it to control the scale of our distribution or our matrix, right? So if I come in here, you can see we have the matrix contains rotation, position, scale, translation, and everything, right? So the dots that we are generating, if I disable this for now, contains all those information, contains rotation, scale, and position, right? So all we want for now, if we come here, in fact, let me actually start organizing this, right? So I'll take the closest point and all of these, I'll take all of them and I'll drag it down here. So, and bring in our matrix up. So we want to use this to control the scale, the voxel size, to control the scale of our dots, right? And how do we do that? We will need a matrix. The matrix compose, like we have to compose our matrix, right? Because right now we have all of them like straight away going forward to this one. So first of all, I'm actually type C and look for matrix, right? And you can see we have compose matrix. So let's bring in compose matrix, and you can see it's broken it down. We have translation, scale, and rotation. So we can simply straight away, instead of connecting this matrix directly into our matrix up, we can just take the translation, which is the positions of our dots, connect it to the translation here, and connect the results to the matrix. And you can see nothing has changed because it's doing the same thing. Now we have the scale that we can use this to control, right? But we don't want to plug it in directly. We have to also, this is a vector, right? So now let's bring in the compose vector. So if I type C once again, I say vector, you can see we have compose vector 3D, right? So let's drag in compose vector 3D, and now you can see the compose vector 3D has like all these ones. So now we can connect our voxel size to X, Y, and Z, and you can see now we now can take this one and connect it to our scale. All right, and now anytime we select, let me actually enable our cube, everything is fine now. So now the scale of our cube or of our matrix or dots is controlled by the voxel size, right? So if I come in here and I set it to 2, can see automatically this one scales up, but it's not really the geometry which is scaling up, it's the dots. But because this is set to 1.1 centimeter, it sort of multiplies it, right? So if I set this to 2, you can see it will be bigger. It will be bigger than the size. So almost, if you set it up this way, then it means that any object that you use should have the scale of 1 centimeter so that it fits perfectly, right? So, and I'll quickly actually show how you can actually, if in case you don't know how to, if you have some random object and you want to set it up, like make it 1 centimeter, there's actually a capsule that easily make it works. I'll show that, but for now this is how you set it up. And you can see, if I now, you don't have to even come in here, can come in here straight up and set our voxel size to 3 and 4, and you can animate it. This is how I actually animated it to make it from, and can set it to 1 again and all of that. So that's basically how this thing too was set up, and it's really straightforward, right? So from here you can click on this to arrange your notes. So this is how I basically set it up. Like, now let me quickly talk about show the assets I was talking about. I think, let me come in here and create something like, say, a sphere, which is very big. If I come in here and I've forgotten the name, but it's actually, and then if I come to nodes and I hit geometry modifiers, I think it's something related to scale. Let me see. No. Should be somewhere in here. I remember I've used it before. Oh, it's crazy. It's been a while. Points, breakdown. Uh, in fact, let me set it to. So yeah, I've seen it. It's called geometry resize. So if I, you can see our sphere is quite big. If I drag in a geometry size and make it a child of the sphere, you can see immediately it gets smaller. And that's the geometry size is set, so it's set to 100. So if I set it to, like, say 1, you can see it will be small, like actually 1 centimeter big. So whatever you have and you put it, if it's also small, so if I create, like, say a cube, which is really small, let's set it to 0.5, 0.1, 0.1 and let's leave it like this. And now if we put the cube, the geometry size, and the cube, right, let's this the cube. Now this one, to set it 0.1, and let's hide our sphere. You can see it will scale it up to the point, like make it 1 centimeter. If it will make sure whether small or big, it always come and to the target size, which is 1 centimeter. If I disable it, you can see it gets even smaller. So it's something that if you have object and you're not sure, you can use this geometry size to set it to the target, and now you can make it current state to object, and you have it actually in that state, right? And now you can use it whatever you want. So this is something I quickly wanted to show. So now that we have this thing set and everything, I'm sure you can naturally go ahead and use it on the same setup with the surface scale blue noise as well. But let me actually quickly show that one as well. In fact, let me actually bring in the scene itself so that you can quickly glance through that one. So this is the scene for the surface. If I actually set it up, you can see it's just one node and just the children up, right? That one is even really easy. All I did is, like, we set it up, have my geometry object group in here, the object I want to clone, which is the sphere, and the surface I want to clone, which is the text. And all I did was to change the distribution mode from to surface scale blue noise. And that one is very important. Make sure the objects you are cloning, or the spheres or the circles, are 1. The radius is always like 1, right? Very, very important, so that he always, because it's a multiplier, right? It takes this size, the maximum size and the minimum size, to multiply it to make it fit. So that's basically all I did with this one. Now let's quickly talk about how to sort of render it, and it's quite easy. So now that I have this here, let me actually also, before I actually show how to render it, let me also show what I did here. So I wanted to use Mograph, or like effectors. So to use effectors to control this, all I did was I made sure my object group if I come to generator, it's set to instance. Now if it's set to instance, then it means every like object is basically on its own. It's not, the multi-instance wouldn't work with this. So now when it's set to instance, I placed it under a Voronoi fracture, or it can even be if I come to, we can place it under a fracture object and make sure the mode is set to explode and connect. So I just placed under a Voronoi fracture, and in the Voronoi fracture I deleted the source, so it recognized this as, if I delete this, you see this as individual spheres, and now we can actually use effectors to control our Voronoi fracture. So if I should come in here and let me delete the delay and select our sphere curve field, you can see, let me actually take off the camera, so you can see I animated the sphere, and you can see it's bringing it on, right? This is actually a C node object, but placed under a Voronoi fracture, and now you can use our effectors to affect it, right? But that's mind if you have a lot of clones. I mean, it might slow it down. So because the mode is set to instance, it might be slow. So you have to check whilst you are working. But this is how you can use effectors for now to control it within the legacy Cinema 4D object manager. But going forward, you'll see how you can actually use effectors directly in the node, if that will be possible. Like, I'll try and explore that one and see. All right, so that's how you use effectors. Now to render it, let me quickly come back to this scene, and to render it, it's quite simple. So maybe I'll use Redshift quickly here. So I'll come in here and I'll create a new material, which is a Redshift material. You can see standard Redshift, and we apply it to our object group, and you can see we have it applied here. And all we have to do is to come in here and type C user. Now you have color user data, right? Bring in our color user data and connect it to our color here. Come into the presets, and let's choose object color, right? I think it's object color. And now if you come into our Redshift render view, yeah, like I said, if you come to our Redshift render view, so if I come to Redshift render view, you can see if I hit render, it shows our object color, right? So here we can add reflections and all of that into our object, and it's quite straightforward, right? That's basically how I actually set up, and this is how to render. I actually use Arnold though, and using Arnold too is basically the same. So I'll quickly change the render settings from Redshift to Arnold, right? And now let's come in here and create Arnold standard surface, right? And I'll apply it to the object group, right? Replace the Redshift one with the Arnold standard surface. And now you can see in our node editor, we can simply look for type C and look for user data RGB. So user data, you can see RGB. Let's drag it in and connect our output in here to the color. And now you can select our attribute, come into the attribute, make sure it's set to display color, right? And now if I come to my Arnold IPR render, you should be able to, if I hit render, you can see it, and that's because we already have Arnold sky in the scene, right? So you can see our renders. If I actually let me bring it here, if I go close, you can see with Arnold 2 you can render our object, right? So that's basically how to set it up. Now let me quickly show how you set the worker one, how that one too was done. So this is a quick scene of the worker one, and you can see it's the same thing, the suffix, everything. If I double click on it, you can see I have the same setup with the this time the closest point and all of that, right? Nothing different. And then all I've done is I've actually applied a dynamic tag to it, and also I have a floor which I've applied a collider tag as well. So, and if I come to the generator, you can see it's set to multi-instance. So if I hit play, you can see it runs, and all I've done is I've keyframed when the dynamics should enable. So the keyframe, it's off, enable is set to off, right? And at frame 75, it comes on and sort of turns dynamic. But one thing I've actually done is that I make sure at frame 75 the animation, the video or the character is not moving. So let me first of all disable the voxelizer and all of those things, and let me hit play. Can see when it gets to frame 70 dives, it stops. The reason why I did that is because the surface is moving or the object is moving, it keeps generating new sort of dots or new clones all the time. So when you apply the dynamics to it and the clones keep changing, it makes it a bit weird and doesn't act. So where I want the dynamics to start like at that frame, I made sure it was like not moving, so that the clones that are generated at that frames are the same clones, and for the dynamic to affect it perfectly. So that's what I did. So now let me go back and now let me enable this, and now let's hit play to see how it works as well. So it keeps running, and then somewhere here the dynamics takes over. You can see it's slowing down because the dynamics, but here basically you can see now it's falling. So that's all I basically did. And also whilst it was running, I scaled the voxel as well. If I come to input, you can see the value was set to 0.5, and whilst the camera keeps moving back, you can see it starts scaling up, right? So that's how I can see it got a bit faster. Got it too. So that's basically how I did this one as well. And I hope you've learned a thing or two, some tricks, and you've learned something which you can actually use in your future project or whatever you're working on. Thank you for watching. And if probably you like the project file or something, let me know, and I probably can share it on like Instagram. Contact me on Instagram or something and let me know, and I probably can share it with you. Thank you for watching once again, and I'll see you in the next one.